All right, guys, let's jump into lesson 9. We're going to deal with quadratics, just like we were doing with the jumping, but now we're going to deal with time. As always, guys, please pause and copy down your notes. So we're going to be putting notes on page 29. And, oh man, I made a typo here. I believe it's going to be your 9th set of assignments, if I remember correctly. All right, so copy down your bottom 2 pieces here. All right, so go ahead and pause and copy this down. All right, so let me tell you a little bit about what's happening here. So if you think about this, the graph of our upside down parabola, our time is what's moving sideways. So our x values are time. And so as time passes, our rocket's going to be going up, and then it's going to reach its height. It's middle of its flight, and then it's going to start coming back down again, just like if you're throwing a soccer ball. But we're not looking at how far it goes. We're talking about its time piece. Now, obviously, the highest this rocket goes, that's going to be its maximum value. And so that's going to be the y value of the vertex, or the k. So what we're going to do is just simply find the vertex. Well, we've got a quadratic, so we're going to do the negative b over 2a. And if the b is 100, it's going to be negative 100. And then over the top of 2 times negative 16. And you can just type this into Desmos and it'll get you the decimal really fast. I just showed the steps. So in this situation, I think a decimal is easier to use. It makes more sense. So then that's the x value. So in 3.125 seconds, the rocket's going to reach its maximum height. So we're going to plug that into the equation to find out what that height's going to be. And so I did the work going down. You could have typed this all in one shot in Desmos, and it would give you the answer in one shot. But it comes out to 156.24. So that's how high it's going to be. In 3.125 seconds, it'll reach a height of 156.24 feet. The problem sounds a lot more complex than it actually is. You just need to get the vertex. Obviously, you can also graph this and get the vertex that way. All right, now let's look at this again, but I'm giving you a different piece here. It's a different equation. So here's a rocket launching from the ground, going up, and then coming back down to the ground. And so the question is, first question is, how long until the rocket hits the ground? So what we're going to do here is we're going to actually use the quadratic formula, because if you remember, when it's on the ground, that's the x-intercepts. That's where it touches the ground. That's the x-axis, starting at 0 for height. So if we do the quadratic formula, it's going to tell us 2 spots where the rocket launched and how long it landed. So I plugged in my 30 for the B, my negative 16 for the A, and then 0 for the C, because there is no C over here. You see how there's, in the problem, there's no adding, subtracting a number on the end? So that's 0. So when you do the quadratic formula, since 0 is multiplying to that back end, it all cancels. And check out what happens. You get negative 30 plus 30. So that gives you 0 over negative 32. And that's this guy right here, x equals 0. That's the beginning of the launch. Like, that's where the rocket is before you started. At 0 seconds, it hasn't left the ground yet. 1.875 seconds later, it will hit the ground. So that's kind of neat. And so what I want to do is I'm going to actually exit out of PowerPoint, and I want to show you the graph of this. Where'd it go? Here it is. All right, so here's the graph of the equation. You can see I typed it in over there in the top left-hand corner. And you can see right here, I've already got it highlighted. It hits at 1.875. That's the x-intercepts. That's how long it'll take to come down. So I wanted to show you this because you can also do this stuff graphically. But I feel like the algebra is really important to practice. All right, the second question was just like what we did before. How high is the rocket going to go? Well, we need the vertex, because we need the y value. So we're going to find the x value first by using negative b over 2a. and I ended up rounding this to 0.938. I plug it in, and I just typed this directly, this part right here. I typed all of this in one shot into my Desmos calculator, and I got 14.06 feet high. So that's the highest this rocket's going to go. And for some reason, I forgot to fix this over here. That's page 29. All right. Guys, this is your assignments. There is a drone and rocket problem. And then there is a height parabolas Google tiles. Go ahead and knock those out. Get them in Monday at midnight. Catch up any work that you're missing. And we are good to go. So you guys stay safe and rewatch this video as many times as you need.